In this question, we are required to show that dy over dx is equal to the given expression, and in part B, we are required to find the equation of the normal to this curve at the point 1, 1. So for part A, to find dy over dx, we shall differentiate this equation implicitly. So for part A, um, we have dy over dx will be equal to, now because we have a product of two expressions here, we shall apply product rule. So x multiplied by the derivative of tan pi xy over 4 uh, plus tan pi xy over 4 multiplied by the derivative of x. Okay, so at this point, we can apply chain rule to differentiate this. But before I apply chain rule, which will mean applying chain rule 3 times, let's first of all consider this part here. So consider y being equal to pi xy over 4. And basically what I want to do is to differentiate that to find out what dy over dx will be, so that when I apply chain rule, I know what to plug in. So dy over dx will be equal to, now this is a product of two functions. So we apply product rule again. So that will be pi x over 4 multiplied by the derivative of y plus y multiplied by the derivative of pi x over 4. So this will be equal to pi xy, pi x over 4 multiplied by dy over dx plus, now here derivative pi x over 4 will just be pi over 4, so this will be pi over 4 y. So now when we come back to this point here, so our dy over dx will be equal to, um, so here we have x, and then derivative of the inside portion is given here. So that will be pi x over 4 dy over dx plus pi over 4y. Let's just put that in bracket. And then multiply by outside. Now derivative of tan is secant of theta squared, but theta is that. So secant of pi xy over 4 squared. Okay, and then we have plus this term here. Now here derivative of x is just 1, so that will be tan pi xy over 4. Okay, we can simplify this to have dy over dx will be equal to pi x squared over 4 dy over dx plus pi xy over 4. And this is just for this portion here, multiplied by secant of pi xy over 4 squared plus tan of pi xy over 4. And now, suppose we want to find um, the gradient of this curve at point 1, 1. So at point 1, 1, gradient of the curve, gradient of the tangent to the curve will be given by uh, so it will be given by, so basically to find the gradient of the tangent to the curve, we shall plug 0.11 into this equation. So basically I really don't need to write this statement here. So at 0.11, let's plug 0.11 into this equation. Um, so the left hand side will have dy over dx will be equal to, so for the first bracket here, because x is just equal to 1, so we'll have pi over 4 dy over dx plus, here we'll just have pi over 4 because x and y are 1, and here we have secant of pi over 4 squared, and this will be plus tan pi over 4. All right, so this will be equal to, so we'll have dy over dx being equal to, now we know that secant of something is same as 1 over cos, so we can write this as pi over 4 dy over dx plus pi over 4 all this over cosine of pi over 4 squared, or just cosine of pi over 4 squared using the other notation. All right, and then plus tan pi over 4. Now pi over 4 is 45 degrees, and we know that tan of 45 degrees is 1, cosine of 45 degrees is 1 over square root of 2. So this expression here can be written as pi over 4 dy over dx plus pi over 4. This is pi over 4 over 1 over square root of 2 squared plus 1. So this implies that dy over dx will be equal to pi over 4 dy over dx plus pi over 4 over, here we have a half plus 1. Now suppose we multiply each term by a half. Yeah, if we multiply each term by a half, we'll have a half dy over dx. So dy over dx will be equal to pi over 4 dy over dx plus pi over 4 plus a half. At this point, suppose we multiply each term by 4. Yeah, so multiply each term by 4. So what we shall end up with is 2 dy over dx will be equal to pi dy over dx plus pi plus 2, which implies that if we bring this in front, so you'll have 2 minus pi dy over dx being equal to pi plus 2. And at this point now, if we, because you're interested in just finding dy over dx, you can now say dy over dx, so therefore dy over dx will be equal to pi plus 2 over 2 minus pi. And that is the required expression that you are required to show in part A. Now, for part B, we need the equation of the normal. Now, remember initially I said that basically this is the gradient of the tangent. Yeah, this is the gradient of the tangent at the point 1, 1. So basically the gradient of the normal at 1, 1. So the gradient of the normal at 1, 1 will be equal to, so it will be the negative reciprocal of that. So the reciprocal of this will just be 2 minus pi over pi plus 2, and this will be equal to pi minus 2 over pi plus 2. So the equation of the normal at 1, 1 will be applying point slope formula. We'll have y minus y1. Now y1 is just 1. That will be equal to the gradient, which is pi plus minus 2 over pi plus 2. So we have pi minus 2 over pi plus 2. That multiplied by x minus x1. And that will be the equation of the normal at the point 1, 1.